Alright, so in this video we're going to be graphing functions with a domain of all real numbers. Okay, in the previous set of notes there was a specific domain that was given to us that we had to use. Okay, and the graph of those functions was just a scatter plot. Okay, when we graph the functions in the following videos, this video and a few more, okay, you're going to have a continuous graph. Okay, the graph's going to be going forever. We're going to connect all the dots, and it's going to be a continuous graph. Okay. So in this video, we're going to be talking specifically about linear functions. So the graph of this, when we're done, should be a line. And we know it's linear because the exponent with the variable here, the largest exponent in this function is 1. Okay? If the largest exponent becomes something other than 1, then the graph is going to change. Okay? But every graph in this video will be linear. All right? So the goals here, we're going to evaluate functions for given values of x. I've chosen these 5. It doesn't matter what values for x you use. You're still going to get the same line, all right? But I've chosen these 5, a couple negatives, a couple positives, and 0, okay? For now, we're going to use 5 values for x to get our graph. As we get better and better at this, we only need really 2 points to draw a line, okay? But for now, we're going to do these 5. We're going to construct a table of values, okay? So we're going to finish this table of values here. We're going to show the work. We're going to get our y-coordinate, and we're going to write it as an ordered pair, okay? And then we're going to draw the graph once we have all these ordered pairs, okay? After we go through a few videos for this set of notes, you're going to need to understand the difference between linear functions, okay, where the graph is a line, quadratic functions where the graph is kind of a U shape, it's called a parabola, and absolute value functions, which is a V-shaped graph, okay, a V-shaped graph. All right, so for now, let's do this linear function, y equals 2x minus 3. So I'm going to use these 5 values, like I said. Let's plug in -2. Okay, so 2 times -2 is -4. -4 minus 3 is -7. Okay, so the ordered pair for that is -2, -7. So we'd go left 2 and down 7. So that point would be here. I'll draw the graph in just a second. Okay, let's plug in -1. Okay, 2 times -1 is -2. -2 minus 3 is -5. So that corresponds to an ordered pair of -1, -5. All right, let's plug in 0. Let's complete this table of values. That gives me 0 minus 3, which is -3. So that gives me an ordered pair of 0, -3. Let's plug in 1. So 2 times 1 is 2. 2 minus 3 is -1. So that gives me an ordered pair of 1, -1. And let's plug in 2. We get 2 times 2 is 4. 4 minus 3 is 1, which gives me an ordered pair of 2, 1. Okay? All right, so let's draw that graph. Okay, so when you look back at the table of values, we had 5 points. We had -2, so left 2, and then down 7. Oop, let me turn my pen on. So -2, -7. Okay? Our next point was at -1, -5. Our next point was at 0, -3, and you can see that it's starting to take the line shape here. Our next point was at 1, -1, and our final point was at 2, 1. Okay? And that goes on forever. That pattern continues forever. So the graph of y equals 2x minus 3 should look like that. Okay? Crosses the y-axis at -3. Looks like it crosses the x-axis in here, kind of in between 1 and 2. We'll figure out how to figure that out a little bit later, okay? But that's the graph of y equals 2x minus 3. All right, let's take a look at number 2 here. The linear function in this case is y equals -3x plus 2. Again, we know that's a linear function because the largest exponent is 1, all right? And there's no denominator with a variable in it or anything else, okay? So this is going to be a linear function. So let's plug in -2. All right, so -3 times -2 is 6. 6 plus 2 is 8. So the ordered pair there is -2, 8. All right, let's plug in -1. So -3 times -1 is 3. 3 plus 2 is 5. So that gives me an ordered pair of -1, 5. Okay, let's plug in 0. -3 times 0 is 0. 0 plus 2 is 2. So that gives me an ordered pair of 0, 2. And when I plug in 1, I get -3 plus 2, which is -1. So that gives me an ordered pair of 1, -1. And when I plug in 2, I get -3 times 2, which is -6, plus 2 is -4. So that gives me an ordered pair of 2, -4, okay? Again, you could use any values for x. These values are pretty small, so the math is a lot easier. So try to use these values when you can. But notice with the y's, we have a pattern here, and that's why we get a linear shape for our graph, okay? So let's graph number 2 now. Okay, so looking at the table of values just made, we had a point at -2, comma 8. So that's going to be up here, okay? The next ordered pair was at -1, comma 5. So left 1, up 5. Then we had a point at 0, 2, okay? This point's called the y-intercept because that's where the graph crosses the y-axis. 1, -1 is here, and 2, -4 is down here. Okay, so you can see again those 5 points formed a line. Because our domain is all real numbers, we want to connect those points. Okay, we want to put arrowheads on the end, okay, because it goes on forever. So that's going to be the graph of y equals -3x plus 2. Okay, if you have any questions, let me know.